Looking at this circuit, we have a connection between a battery V1 and 4 resistors. So the first thing, let's identify all the terminals of the components. And we have here for the battery the first and second terminal, and for all the resistors we have these terminals. So with black lines are represented the cables connecting all these components together. So secondly, let's identify all the points in the circuit. And by definition, a point is a junction terminal in certain part of the circuit. And everywhere we have a junction of cables, that junction can be called a point. And in practical and theory, a point cannot bypass an element. So if we have a resistor and we have a point here, let's say A, this point cannot go to here, or we can call this point also A and this A, because this element is making a separation between this line and this line. So that means we only have the point A here, and the last position of the point A is here in the terminal of the element, and in another terminal we have a new point. We can call this B, and this B can be here also because we have no elements here. So looking at the circuit starting from the battery, we have no junctions here, but we have a junction here. In this junction, as already have a name, and this is A, this is called the same point because there is no elements here. And continuing, this A can be here and also here, but cannot go to this point here because there is an element blocking this point to go from here to here. So going forward, the point A can also be here but cannot go to here because the resistor 3 is blocking, and the point A also cannot go to here because the resistor 2 is blocking. So the point A is limited to only these locations. And going down, we already have the point B. As you can see, B is also here, and B cannot go to here because the resistor 4 is blocking, but can go in this direction. Here we have B. Also we have B in this region. We can connect a terminal here and call this B also. This is the same point, no resistors are blocking. Also B can go to here and to here. So as we can see, B was not able to go from the resistor 4 directly, but he was able to go in this cable and to here. So all these points represents the point B. So points have two basic properties. The first is that you can insert a new point in any part of the circuit so that you can study the behavior of this certain part of the circuit. That means if we have the possibility to connect a new element from here to here, this is the point B, this is a new point, and if you want to study the behavior of the circuit in this point, you can add a new point here and call this point C. And the second property is that a point is free to move on cable if no obstacles are present. That means this point C, I can move this point C because this is the same point here. I can move this point C to here or move it to here. And also the point B, I can move this point B to this point because this is the same point. In all these regions, the same happens to A. The A can be moved to here. And these operations of moving a point is important to reorganize the circuit when you are simplifying the circuit. And you will understand it later in circuit simplification lecture. And let's clear the circuit. And another important operation is short-circuiting an element. And this operation is useful if you want to remove an element from the circuit. And sometimes you will find a short circuit in specific elements, so you can remove this element from the circuit to avoid many steps and complications in circuit simplification. And the short circuit is a low resistance connection between two or more points in a circuit. So if you have a resistor association like this, you have the point A here and another point B here. You have the resistor 1 and resistor 2 here. If you want to remove the resistor 2 from the circuit, with the cable you connect this terminal of the resistor 2. So doing this, when the current is flowing in the circuit, the current will go to this point, and as we said before, the resistance gives an opposition and limits the passage of the current and the electrons. So the electrons prefers to pass in a low resistance, so they will choose this way to go from A to B, because this path has no resistance and will not block the passage of current comparing to this of the resistor 2. And in the resistor 2 no current will pass. The current in the resistor 2 will be equal to 0. And when we connect this terminal of resistor 2 to the point B can also be right in here, passing through the cable, because we already removed this resistance. So you can clear the resistance, and the new circuit will be the resistor 1 connected between the points A and B. So looking at our circuit, we can see that we have the resistor 4 connected between the same point. This is the point B and B. And as we have seen in the demonstration, when a resistor is connected between the same point, that means this resistor is short circuit. Let's confirm. This resistor is connected here and to here, and there is no elements here. This is only a cable. So that means this cable is short circuiting the resistor 4. And when this happens, you can simply remove this resistor from the circuit. And now, as I said before, for better arrangement of the circuit, we can move the point B to this location here and clear this cable. This is the circuit from the previous lecture, and we discovered that the resistor 4 was in short circuit by this cable. Removing the resistor 4 and transferring the point B to this location, we are now in a certain disposition of the circuit that can be reorganized. That means, for a better visualization of the circuit, if this is the same point B, we can transfer not only points but even this cable, because this cable is also point B. We can take this cable and instead of connecting here, connect this cable here and delete this cable. So doing this, we are not changing the circuit connections, but we are just organizing the circuit. And finally, this circuit will be like this for a better visualization. So now that we have a better organized circuit, let's identify all the branches. A branch is a non-interrupted row with elements connected in sequence. So let's draw some non-interrupted rows in the circuit lines or cables and check how much branches do we have. So I will start from the point B, and I'm drawing some non-interrupted line, and I pass through the voltage source V1 and the resistor 1. When I finally get to this point A, the line is interrupted and divided in two other lines, the line that goes to the resistor 2 and the line that goes to the resistor 3. And the same happens in point B, because in B we also have the interruption and the line is divided to the resistor 2 and 3. So doing this, we have the first branch in the circuit, and this branch is composed by two elements, the voltage source V1 and the resistor 1. So let's check if we have more branches. Continuing from A, I will draw a continuous line passing through the resistor 2, and when I get to this point B, my line is interrupted and divided in two other lines. The first that goes to the voltage source V1 and the second that goes to the resistor 3. So that means in orange we have the second branch composed by one element, and this is the resistor 2 in this branch. And the last branch, starting from A, drawing a continuous line, we pass through the resistor 3 and we get to the point B. The line is also divided to the lines that goes to the resistor 2 and the other that goes to the voltage V1. So that means from A to B we have another branch composed by one element, the resistor 3. So now that we have defined a branch and identified all the possible branches in the circuit, let's introduce node. And by definition, a node is the point in which three or more branches are connected. And as we have seen in the previous lecture, we identified this point as A and this as B. So starting from these 2 points, we are looking for which of the 2 points are connected to 3 or more branches. So the A is connected first to the branch 1 identified in red, are connected also to the branch identified by orange, and are connected also to the branch identified as blue. So that means this point A is also a node. So another point in the circuit is the point B, and the point B is connected also to the branch that goes to the V1 and R1, and second the branch of R2, the branch that goes from the R3. So that also means that the point B is also a node. So we don't have any more points in the circuit, and that means there is no more nodes in the circuit. So let's suppose if by the property of the points we created a new point here and we call this point C. So looking at this point C, the point C is only connected to 2 branches. If we divide the circuit like this, the first branch will be between B, V1, and will end here, and the second branch will start from here, C, and end in the point A. So that means the point C has only 2 branches, and this is not a node in these conditions because only 2 branches are connected to the point C. So another important theory about nodes is that in a node, let's call this A, when a current comes to the node, the current is splitted into 2 or many other currents according to the number of branches connected. So if we have 2 branches connected to A, the current will be divided in a current, let's call line, and the second current will be double line. So if we have a node A with 4 branches connected and the current is coming from here, this current will be split in 3 different currents. The first will go to this branch, the second to this branch, and the third to this branch. So this doesn't happen in points because looking at the point C, the circuit here in C, we don't connect nothing, just a terminal. The current will go from V1 and there is no circuit for the current to go here in C because this is open. The electrons needs to close a path from the negative and going to the positive. So going to C, there is no more circuit or connections between the positive and the negative. So the current will not go to C, instead the current only goes to here. When this current reaches the node A, is divided by a current that goes to the resistor 2 and another current that goes to the resistor 3, and when these 2 currents get to this point B, they get together and results in the same current that needs to go back to the negative of the voltage source. So this is the difference between a point and a node. In a point the current is not divided, but in a node the current is divided. So now let's introduce loop. Loop is a closed path in circuit conductors composed by elements, branches, nodes, and points. And to identify a loop, we are going to draw continuous lines, and to be closed, the start point of the line must be connected to the end point of the line we are drawing. So let's start from B. Let's draw a continuous line and passing through the conductors or elements. So if I cross here, my start point is together with my end point of the red line. So this is the first loop. And let's identify the second loop. I will start from B, going to A, and I cross this part of the circuit, and finally my start point is together with the end point. So this is the second loop. And the last loop we can do in this circuit is drawing a line from B and using together these components of this branch with the components of the last branch. So we have three possible loops in this circuit. The first, we started from node B, we crossed the voltage source 1, the resistor 1, the node A, the resistor 2, and we ended the line. So this was the loop 1. And the second loop, we started from node B, we crossed the resistor 2, node A, resistor 3, and again in the node B, and that was the loop number 2. In the last loop, we crossed from B, the V1, R1, node A, R3, and we go to the B. So that was the loop number 3. So doing the loop, this is important to know that you have to identify all the possible loops in order to, with the lines, connect all the elements together. The loop 1 connects V1, R1, and R2. The loop 2 connects R2 and R3. And that was missing only the connection between the voltage source R1 and R3. That's why there is the existence of the loop 3. So doing this, we connected all the elements with the loops.